Thank you so much. Thank you so much, Dr. Subarao, for the great introduction. I'm Tom Choi, the founder of Airspace, and I have about 25 years of experience in the satellite communications industry. I wanted to share some of my ideas and thoughts of the what's going on in the market, and as an experienced entrepreneur providing satellite services and all around the world, and with India opening up, I wanted to give my thoughts and views and suggestions on how India could greatly benefit from this great explosion of ideas and creativity and financial investment that's coming into the market. And I commend the Indian government and the regulators for opening up this space opportunity for entrepreneurs and commercial companies so that they can bring in their energies and ideas and motivations to greatly improve the communications requirements of all the vast numbers of people in India who could be bettered. Their lives could be improved by more communications being available at a lower price, lower cost. So I wanted to start off and just hit the nail on the head. In the satellite communications industry, this has been a big news. There's basically $100 billion war that's going on, waged by billionaires like Elon Musk, Jeff Bezos. These guys are developing satellites and providing capacity and thousands of satellites. $100 billion is going to be invested into the world, providing broadband communication services. But and a lot of people are afraid, especially the geo satellite operators, and the regulators are trying to cope with what should we be doing with this. So, but does it really mean what what the sponsors are thinking? So I wanted to just share with you these slides. Let's take a look at this antenna that's being used by Starlink. Elon Musk calls it Dishy Mr. McFlatface. It's a cute name, but inside of this antenna is a very complex, high sophisticated technology composed of hundreds of microprocessors, RFICs, ASICs, and this antenna is able to track low Earth orbiting satellites. And I think for me, it's an engineering marvel. But it also at the same time costs a lot of money. Microprocessors cost a lot of money to fabricate. I heard that it costs somewhere above 2,000 US dollars to manufacture. They're subsidizing it for $500 and getting the money back from the $100 monthly subscription fee. But even if it's subsidized at 500, can people in the emerging markets afford $500 user equipment? I would say no. Where the 3 billion people live, South America, Africa, Sub-Saharan Asia, Southeast Asia, Pacific Islands, the economies of these countries are, compared to the emerging market nations, relatively and much lower. The GDP per capita of countries are below $100 a month. So how can these subscribers afford such an expensive user terminal? So I think the approach that everybody that you saw on the list, including OneWeb, Telesat, Apple, and everybody else, Starlink, they're having expensive terminals. And this is not the solution. I believe there's room for entrepreneurs, and I hope they come from India, to redefine the low Earth orbit with a better solution for lower cost terminal than what we're seeing here. And then because of the terminal is consuming so much electrical power, the electricity bill, they estimate in the US, $100 antenna, 100-watt antenna that's consuming 100 watts of power, sometimes bursting up to 200 watts, is about $25 a month. But if you look at the electrical tariff rates of emerging market countries, they're sometimes double, triple, 10 times more than the electrical power rates of OECD countries. And in emerging market countries, I would say over 1.2 billion people in the world do not have access to reliable power or any electricity. So to have a system that you're trying to develop to address the needs of 3 billion people, when you require that user to have power that they don't have, I think, is misaligned with their goals. And then because these systems are so expensive, the technology choices that they've made, because I think a lot of these billionaires, they live in Silicon Valley, they live in high class posh apartments in Manhattan. They're not where we are, and they're not seeing how everyday people are living. So their math is kind of, I think, off a little bit. So their tariffs that they want to charge $100 a month is too expensive. $3. I've heard some of the other Leo systems want to charge about $3 a gigabyte, but the emerging market consumers can only afford about 10 to 20 cents a gigabyte for their mobile tariffs. So the pricing is like 10 times higher than what people can afford. So I would say, never mind these billionaires that are waging $100 billion war at Leo, fighting each other for bragging rights. What they've produced so far is not relevant to the rest of the world. I think we need to create a solution that works for us, for India, for Africa, for Southeast Asia. So, so here's the current satellite broadband market today. It's about $12 billion, and this is a forecast from Northern Sky Research. They're saying that it's going to double in value over the next 10 years. The biggest component of this revenue is not coming from LEO broadband. It's coming from GEO high throughput satellites. Why? Because GEO satellites are stable. They don't move. You don't need moving antennas. The terminals for GEO satellites only need 25 watts of power, not 200 watts. The amount of bandwidth that you could put over a country is from a LEO, from a GEO orbit, is much higher than you can from one of these LEO systems. So the densification of broadband from the GEO orbit is much higher. So I would say the first path towards giving broadband connectivity in India should be a GEO satellite, and there's opportunities for LEO systems to additionally add additional capacity, but I don't think we should be wary of these LEO systems and not focus on being able to use GEO satellites to deliver a low-cost solution. So, but not everything is rosy with GEO operators. I wanted to share my experience as well as my knowledge of where these operators are today. Most of the GEO operators, regional and global, they're kind of struggling because their revenues are slowly falling. Their EBITDA is being affected. Their debt level net to EBITDA is increasing, so they're having fiscal pressure, which impedes their ability to make big investments in the high throughput satellites that are needed for them to be relevant in the future. And because competition is coming from LEO HTS, they're wide beam satellites that are being used to cover an entire country, which are more expensive per bit than a HTS satellite, which uses spot beams. They're becoming less and less relevant, becoming more obsolete. So there's a significant level of pressure coming on the GEO operators, but there are also additional opportunities as well, especially in places like in Asia. In Indonesia, for example, there's a national drive to deliver broadband to all the rural communities in Indonesia. Indonesia has 250 million people. Half of them do not have internet access. So they've made public statements that more than 1 terabit of capacity is needed to address the broadband digital divide. And they're taking steps to buy 50 gigabits, 100 gigabits at a time. And they're going to be continuously coming out with demand and requests from regional satellite operators to bring capacity to Indonesia at a lower rate. Now, we haven't seen such an emphasis in India, but I think if the Indian government wants to invest and bring up the rural communities with internet access, they could certainly look to the GEO orbit and local as well as international companies to also provide capacity. But I would say in India, the pent-up demand is so high that the commercial companies who are needing VSAT services and regular data services would be enough to drive huge levels of demand for geosatellite capacity for the next few years. And then maybe later, the rural community development could come into play as well. So this is my last slide, and I'll probably spend the most amount of time on this, is I feel that right now, this is a fantastic time for satellite communications in India because of what I said earlier, because the Indian government has opened up the market for commercial entities to participate. I think so as long as there's a very well-defined rules, sets of regulations that allows new GEO as well as NGSO operators to come into the market, I think there's going to be billions of dollars coming into India, the aerospace opportunity in India. Why do I say that? There's pent-up demand, as I mentioned. There's commercial companies that want more capacity. And then there's a huge addressable market. You have India is going to be the biggest country in the world in terms of population, and you still have a big percentage of the people that need capacity. So as long as the rules and regulations are well defined that protects investors, I think there's no limit to how much money that could come into India. And then the second point, I think so as long as the regulations also allow for participation of foreign orbital slot operators, then what Israel's done a fantastic job. They have more than a half a dozen orbital slots over India, well coordinated CKUK band, but those slots are not sufficient enough to meet the demand of the domestic market. So if you wait for India to go through the ITU rules to achieve priority, that's going to take too long. So I think it's much better to, at least in the interim period, work with foreign slot owners that have dozens of orbital slots above India to allow them to use their spectrum in a participation in a partnership with local companies to provide that capacity in India. If that's the case, then you would dramatically increase the amount of available geo spectrum that could be put over India for data services, broadcasting services, etc. And then I would argue this NGSO rules and regulations should be carefully examined and implemented because although I'm a satellite personnel, I have worked with ITU rules all my life. One thing that I do not agree with is this concept of ITU priority, because the first company that actually put up one piece of satellite in one orbit plane of their filing now has somehow ITU priority over the KU band or Ka band spectrum globally. I don't believe that. I don't think that makes any sense. That makes as much sense as some Martian coming in from Andromeda and saying that I flew a spaceship next to your country and I made some announcement and you didn't follow, so you're now our territory. It's almost as absurd as this. The LEO satellites are very close to the Earth. There's almost no difference when a LEO satellite passes behind a mountain or a tower versus spectrum that's regulated on a piece of hardware that's on a tower. So I think all LEO systems should be regulated domestically, locally, and I would highly advise the Indian regulators to follow the example of the FCC. The FCC, in their own planning, have decided to give licenses and landing rights to certain networks. And it doesn't matter who got the license first. Their rules state it doesn't matter whether I gave you the license first or the last. All of you share the spectrum. This is a national resource. Everybody share this spectrum on an equal basis. You coordinate with each other. Don't cause interference. Everybody reduce your bandwidth. So if you follow the FCC example, then you will enable international guys that are operators that are already in the market. And you would also enable local operators to launch their own satellites. And not one company would be disadvantaged by the fact that they came 5 years later or 2 years later. The spectrum above the skies of India is a national resource that belongs to the country and its people. And I would highly recommend that India does not follow the ITU rules and saying one network has priority. Everybody needs to coordinate with them. So why I'm kind of passionate about this is because in the GeoArc, there's the GeoArc, the GeoOrbit is one line or one arc in the sky. There's already a lot of satellites there. We're going to be running out of bandwidth. We'll run out of C-band, K-band, K-band, because the satellites cannot be too close together. So once the GeoArc is out of capacity, we have to use the NGSO, non-GeoArc, for additional bandwidth. So we have the opportunity to license, so as long as the regulations conform to allowing all the operators to use the spectrum, the NGSO orbit is an opportunity to create unlimited bandwidth above India, to really give broadband to every consumer that's out there. So I would highly encourage the regulator, when they're making their definitions and rules, that they've copied the FCC model. And final point is that because of your market, because of your strength and the size of your population and how much potential demand that you could be generating, I think, could you not kind of encourage domestic as well as foreign operators to make in India all the satellites, launch vehicles, ground terminals? Because if you're able to do this, you will encourage these investors to think in that context. So you get the double benefit of not only giving connectivity to your rural communities, but you're also developing your human resources capabilities and your technology and research. So I think the times are fantastic for India. The SIA is a right organization. There's so much interest in the sector, and I wish India SIA the best in being able to develop their space capabilities. And these are my recommendations for a very productive and a fruitful future for the commercial operations of satellite services in India. So thank you so much. That's the end of my presentation.